On the occasion of National Science Day 2022, on behalf of Atomic Minerals Directorate for Exploration and Research, AMD Hyderabad, I extend my warm greetings to our respective chief guest, Professor P. Appa Rao, a renowned scientist in the field of life sciences, our revered director, Dr. D.K. Sinha, Dr. T. Srinivas Mindi, BRC, Additional Director, Shri B. Sharvanan Sir, Dr. T. S. Sunil Kumar Sir, and Shri R. Mamalan Sir, all regional directors, group heads, in charges, officers, dignitaries, and others present and virtually connected, as we are connected through web link with all other regional centers and others also. My special wishes on this day for the large student fraternity, the torchbearers of the essence of today's function, and their teachers who are present with us and also connected virtually. I shall read out few of the names of the colleges and the schools who are attending the function with us. ZPHS Gachibowli, ZPHS Afzalganj, HBS Ramanathpur, TSWRDC Badvel Hyderabad, Shri Adarsh Junior College Secunderabad, Government Degree College for Women Begumpet, Pragati Vidya Niketan High School Ambarpet, Udhav School Rasulpura Begumpet, AV College Durmalgura, St. Francis College for Women Begumpet, Indira Priyadarshini Government College for Women Nampalli, Government Degree College for Women Hussaini Alam, BJR Government College, Vittalwadi. These are some of the colleges and the schools who are participating with us. I now request our chief guest, Professor Rao, Director and Additional Director OP2, to please grace the dais, sirs. I request our director to present a flowering sapling to chief guest as a welcome gesture. Sir, please.
Thank you, sir. Yes, good.
Thank you, sirs. On this day, we celebrate the momentous occasion of the discovery of the optical phenomena of scattering, Raman effect, introduced by the great scientist of all times, C.V. Raman. This led to a cascade of scientific discoveries, prompting the young generation to imbibe the scientific temperament, then let their imaginations run wild, and finally try connecting the present with the future using the strings of science, which would lead to discoveries and inventions which seemed impossible and will go a long way in the development of the society as a whole. Every year, celebrations speak of a different theme, and this year's emphasis is upon an integrated approach for sustaining livelihood, sustaining human life, and for India to emerge as leaders in science, as said by our Honorable Minister of State. So let us come together and celebrate the different flavors of science and innovations with an integrated approach. I now request our Additional Director, OP2, Shri R. Mamalan Sir, to welcome the audience. Please, sir.
Good afternoon, everybody. Chief guest of today's function, esteemed Professor Appa Rao Garu, revered Director AMD Dr. D.K. Sinha, Dr. T. Srinivas Mindi, BRC, Sri B. Saravanan, Dr. T. S. Sunil Kumar, Additional Directors, my dear colleagues here, teachers and students from schools and colleges, regional directors, colleagues and students in the participating from the regional offices in different regions, who are connected through WebEx and YouTube. A warm welcome to all of you to the National Science Day celebrations. So the first Asian to get a Nobel Prize in Physics is Dr. C.V. Raman. On this day, February 28th, in the year 1928, Sir C.V. Raman discovered the Raman effect. For this contribution in the field of science, Sir Raman was awarded the Nobel Prize in Physics in the year 1930, 2 years after the discovery. Sir Raman was born on November 7, 1888 at Tiruchirappalli in Tamil Nadu. His father was a lecturer in physics and mathematics. Sir C.V. Raman completed his MSc degree at the Presidency College, University of Madras, at the age of 18 with the highest distinction. At that time, there were not any established infrastructure for scientific research in our country. And so he appeared for a competitive examination for entry into the finance department. Actually, Sir C.V. Raman was second of the 8 siblings, and his elder brother was already in finance department, so he preferred, he was rather forced to join the finance department of Government of India. Being very bright, he secured the top position and was selected as Assistant Accountant General, Finance, Government of India, and he was posted in Calcutta. He was only 19 years when he took up the job. One day, on his way to office, Raman noticed a building with a board, Indian Association for Cultivation of Science. He met the then director of that institute and expressed his desire to conduct research. Raman was immediately invited to start his research work in Indian Association of Cultivation of Science. On February 28, 1928, Raman led an experiment on the scattering of light, where he discovered what now is called the Raman effect. A Raman effect is a change in the wavelength of light that occurs when a monochromatic light is scattered by molecules. When a beam of light traverses a dust-free transparent sample of a chemical compound, a small fraction of the light emerges in directions other than that of the incident beam. Most of this scattered light is of unchanged wavelength, but a small part have wavelength different from that of the incident light. This phenomenon is known as Raman effect, which led to a cascade of new discoveries. Interestingly, the apparatus in the illustrious invention by Raman was very, very rudimentary in nature, that contained a mirror to reflect the sun's rays, a lens, a pair of complementary glass filters, a flask filled with benzene, and a pocket spectroscope. At that time, the total cost of the setup was barely 200 rupees. This is the apparatus with which he conducted he made the invention and won the Nobel Prize. In 1986, the National Council for Science and Technology Communication proposed Government of India to celebrate February 28th as National Science Day. Since 1987 onwards, the National Science Day is celebrated in India on this date, February 28th, to commemorate the discovery of Raman effect. The main objective of National Science Day celebration is to bring awareness among people about the importance of science in our daily life and to encourage people to nurture science by popularizing science and technology. It is also to motivate students on the thrills of science and to encourage them to inherit science as a career option. Every year, the National Science Day is celebrated with a particular theme. I remember in the year 2012, the theme was clean energy option and nuclear safety. It was related to our department. But for the current year, 2022, the theme is integrated approach in science and technology for sustainable future. In AMD, Science Day is celebrated every year with great enthusiasm. As part of the celebrations, a science exhibition is organized where multidisciplinary activities involved in atomic mineral exploration are displayed in the form of exhibits, models, and posters. AMD scientists explain and interact with students and visitors the science and technology behind the mineral exploration activities. Popular lectures on science and science by eminent scientists, and essay, post, and quiz competitions are organized for school and college students. But in the past 2 years, because of the pandemic, the Science Day celebrations are curtailed with a limited number of student participation. As a part of Azadi Ka Amrit Mahotsav and coinciding with the National Science Day celebrations, an All India online quiz competition was conducted by AMD on 8th January, and an essay competition was held on 22nd January for 4 category of students, that is class 6 to 8, 9 to 12, undergraduate and postgraduate students. More than 4,500 students from 200 schools and colleges across the country, from Kerala in the south to Arunachal Pradesh in the northeast, they very enthusiastically participated in the competitions. The quiz competition comprised science questions, and the topic of the essay competition was nuclear energy and climate change. The winners of the quiz and essay competitions will be announced in this function. For today's function, students and teachers from 13 schools in and around Hyderabad, schools and colleges in and around Hyderabad have been invited. One batch of students and teachers are sitting here. Another batch of students have joined the celebration through video conferencing from another hall in the campus. Apart from this, regional centers of AMD and a number of schools and colleges have also joined the celebration through WebEx and YouTube. For the invited students, a conducted tour of various laboratories and our library has been arranged. One batch I had already seen, the other batch will go now after the function. The students will also visit the Atomic Mineral Museum and physically see the ore minerals and rock specimens that contain uranium and other atomic minerals. So once again, I welcome the dignitaries, my colleagues, teachers, and students to the National Science Day celebrations. Thank you. Thank you.
Thank you so much, sir. I humbly request our director, sir, to address the gathering. Director, sir, please.
Namaskar. Good morning to you all. On the occasion of Science Day, I welcome here our chief guest, Professor Dr. Appa Rao. He was former Vice Chancellor and he is well-known academician. So we decided that he should participate with us and address the student on the occasion of Dr. C.V. Raman's memorable Science Day. My colleague, Dr. Sunil Kumar, Sri Sarvanan, Dr. T. Srinivas, Dr. R. Mamlan, and the other colleagues, scientists from AMD, Administrative Accounts Officer, and above all, the participating students and teacher for whom this function is made, and for the awareness point of view, for the rejuvenation of science, this function is being conducted. As we know that we are celebrating our 75th years of independence, and under that, many programs are being planned throughout the country. Just now we have been a part of one program which is concluded at National Institute of Nutrition. Professor Appa Rao was chief guest there. I also participated in that program, and directly we are coming to this place. And that was a 6-day long celebration exhibiting many stalls, many scientific developments. A good effort was seen there in the Science Day related program proposed by Government of India. This year, being 75th years of independence, the stress is more that we should highlight our scientific development in 75 years, and we should look forward for next 25 years to reach to 100th year of celebration, which is likely to be there in 2047. Coming back to a very good description given by my colleague Sri Mamalan for Science Day celebration background, for C.V. Raman, and the program conducted in this department. This is a part of Department of Atomic Energy, where we are given mandate to provide the raw material to the department. Raw material includes everything. This is in the form of minerals mostly, and raw materials are always good for any society. Ultimately, science starts from all those things which are needed for us. Rocks, natural resources, whatever things are there in the country, they are meant for our society, and they have to be used scientifically. We are using them, we are rather overusing them, and ultimately we are creating pollutions out of that science. So now a concern is raised. It is a very important concern that science is developing, but at the same time, science is creating trouble for our life. Probably, if we see the troubles what our grandfather faced, we are facing much more troubles in a form of disease, in a form of stress, in a form of many, many aspects of life. So whether it is a scientific development, probably yes, when good thing comes, bad thing also comes. Now this is the responsibility of all of us, being scientists or being a student of science, that we should look forward, that we should manage those bad part of the science. Bad part means the pollution, the trouble or the stress generated by the development. Plastic means, for example, soil pollution, for example, water pollution, for example, weather change, for example. All those things are related to our development, scientific development probably. Everywhere science is there. So this is the time when we should take a note of development and our responsibility to contain the bad part of that. Being a student of science, being a part of scientific community, the responsibility lies with all of us. Science Day gives an opportunity to remember our great scientist, C.V. Raman, and think for further development of good science, which should not give us the things which I just discussed, which should give us a good environment, good society, and good development. I always say that this is the responsibility and this is the final direction where the science should take. In AMD, we are dealing with mostly, as I said, with rocks. Rocks ultimately gives you soil. Soil is already related to the availability of water resources as well. All these things, whatever things are available, we are dealing with. And that ultimately creates a very good environment for our development. Why we need science? We need science for the development, for the happiness, or for the peaceful life. That should be our goal. That should be our motto. Science is nothing but it's a practice, it's a systematic development of knowledge. It could be anything. It doesn't mean that it's a physics only. It is a only development of a systematic knowledge for gaining, for understanding the processes, physical processes, the ultimately to be used for our own purpose. In AMD, we provide that opportunity on this day that you come closer to us, see what we are doing, how the mineral resources, how the soil resources, how the rocks ultimately help us to build our nation strong. Nowadays, energy is very, very important issue which everybody is facing. You can imagine a day when you don't have electricity or you don't have electricity to recharge your telephone, and then ultimately you can realize the importance of energy. Energy has to be there, but what type of energy? Energy has to be a clean energy, not the energy which ultimately gives you power, but at the same time gives you a bad environment. Bad environment or the environment where you can enjoy the energy, and that probably is the atomic energy. We may not be understanding right now the importance of atomic energy, but after 5 years, 10 years, 20 years, this fact will be made realized that the coal-fired plants or the coal-related generated energy or the energy generated by other resources, petroleum-related, gas-related, they are going to provide a bad environment. Good environment has to come, energy has to be there, nuclear energy is the option. Being part of atomic energy, we are providing support for the development of energy when India will be having a self-sufficiency in atomic energy. Atomic energy gives energy as well as many supportive activities are also generated, rather spin-off technology type of thing, if I say, are there with reference to atomic energy. What are those? We need many resources. Earth has got limited resources. The resources has to be improved. How those things can be improved? For example, if we have one seed of paddy, which is having some days of ripening, but it can always be improved upon by using the atomic energy. Yes, using the atomic energy is the option where the ripening time can be reduced and the yield can be reduced. All such type of things are the spin-off technology. So atomic energy is also contributing in development of your agriculture, in horticulture. Horticulture is a very modern field where the shelf-life of particular item is enhanced. We know that mango ripes within 5 days. If you are not consuming your mango within 5 days, it gets rotten and then you cannot use it. But if the lifespan of mango is enhanced 35 days, then you can keep that mango in your fridge and you can use whenever you are in need. So that type of technology is being also developed by atomic energy. We need pure water. We need water from sea also. All those technologies are a part of Department of Atomic Energy, which is being developed, which is being shared, and which is being practiced in all over India. So I welcome you all the students as well as the teacher who are participating here and have an experience of work or the jobs being done in atomic energy, how we are helping the society, what are our societal responsibilities which atomic energy is conducting through various departments. We are in fact 22 units which are associated with atomic energy, and AMD is one unit where we have the responsibility of providing the fuel material or providing the natural resources for processing and utilization. Considering all those items, you will be exposed, you will be given that opportunity to visit the laboratory, to see the scientific development, what are the developments are there in the country, and enjoy your time at AMD and in this Science Day celebration. We have with us today Professor Apparao, very eminent scientist as well as a very eminent speaker on science-related issues, and he is going to speak, and we will be waiting for his scintillating speech in which he will be covering with students as well as with scientists the message what I am expecting from him. I thank all the participants who are participating in physical mode as well as the participants who are associated virtually. I am able to see many participants here, all India basis. If I see in charge BSY from Visakhapatnam, along with many students, he is sitting. Shillong, many people are sitting. Jaipur, many students are sitting. So all those students are participating through virtual mode in this. And then many regions are there, Nagpur, Bangalore, Jamshedpur, and many people, those who are associated through web mode or through YouTube. And these programs will be available in YouTube channel. You are free to watch it subsequently. If you are not able to listen right now, not able to concentrate it, maybe because of some reason, then you can watch it subsequently. So the message, the material, whatever is being discussed here, deliberated here, are available for subsequent watch. Thank you very much for coming to this place and participating in this Science Day. Thank you.
Thank you so much, sir, for your very informative and thought-provoking address. AMD publishes its own newsletter annually and tells about its activities. Now I request our director to kindly requesting our chief guest to release this year's AMD newsletter. Thank you, sirs. We are very fortunate to have amongst us a great educationist, a renowned scientist, and a dear teacher to many, Professor P. Appa Rao, amongst us today. He needs no introduction, but for the sake of the student fraternity and their faculty, I shall read out a brief biodata of Sir. Professor Appa Rao has over 32 years of teaching and research experience. He served as the Vice-Chancellor of the University of Hyderabad and is currently a senior professor. He works in the area of molecular plant-microbe interactions with a more recent focus on the soil and crop microbiome of legumes. His research group critically examines the chemical signals in plant microbe interactions with special emphasis on cheto-oligosaccharides and root exudates. Professor Appa Rao is an elected fellow of all major science academies, including the Indian National Science Academy, Indian Academy of Science, Bangalore, National Academy of Agricultural Sciences, New Delhi, National Academy of Sciences, Allahabad, to name a few. He is recipient of several prestigious awards like J.C. Bose Fellowship from DST, Tata Innovation Fellowship from DBT, K.C. Mehta Memorial Award in Crop Protection from National Academy of Agricultural Sciences, Rangaswamy Award in Agricultural Microbiology from the Association of Microbiologists of India, and so many more. A committed teacher, Professor Rao has guided 24 students towards their PhDs, besides 4 MPhils. At present, 5 PhD students and 2 postdoctoral fellows work in his group. Currently, Professor Rao's lab is supported through a SERB grant and the J.C. Bose Fellowship from DST, with a major research grant in nanotechnology from DBT. Professor Rao has a formidable publication and citation record with about 110 papers in high-impact journals and about 25 book chapters with over 4,400 citations with H-index of 38. He shall be speaking on microbes and sustainable agriculture, a highly applicable topic, especially for countries like India, which are agriculture-based. So please, the floor is yours now. We'll make. Yeah.
This may not be required, this has a pointer. Good afternoon, everybody. At the outset, I would like to extend greetings to everyone, those who are physically present here and those who have joined virtually. The Science Day greetings to every one of you. I would like to thank the director, Dr. Sinha, and his colleagues at AMD Hyderabad, and the participants, the director's team, for inviting me over here to share my thoughts on a science day with all of you. And to all of you, the teachers, the students from colleges and from the schools, for actively participating in the events organized by the AMD and also making your presence here either physically or virtually. I'm sure you all join this celebration, Science Day celebration of AMD, on a special year, the 75 years of independence, Azadi Ka Amrit Mahotsav. On this occasion, I'm so happy to be with all of you, and I thank the lady who has read out the biodata for her kind words. I was wondering, when I was contacted to share my thoughts on this occasion, what is that I can speak. On one side is the AMD, the scientists, other staff. Other side will be some teachers, and then there are also children. How do I make a balance? How do I strike a balance for a lecture of this kind? I thought I will have some mostly visual pictures, and I can always extend them to the most advanced scientific information, and I also can make them as simple as possible for a common man to understand. Let me see if I can convey the message through this. Maybe I would try my level best to do it in about 50 minutes, so that if some of you are inquisitive to know something more, maybe I can always help you to understand a little more of that. That 10 minutes I can allot for that. All of us have gone through, I don't know whether we are still going through, the pandemic. The pandemic has created a confusion, has created a fear in our minds that a virus born in Wuhan moved along in all parts of the world, and then everyone is afraid of. Similar situation has happened some 100 years ago, and after another 100 years now we are facing that pandemic. Lots of people have lost lives. Lots of people suffered from various problems and continue to suffer post-infection. All of this has been happening. This only created a fear in the minds of the people that microbes, the invisible ones, always could be dangerous. Yes, they can be dangerous. We have seen, and we don't have to substantiate that they can be dangerous. But at the same time, not all of them are dangerous, and some of them are important for us. They are very important for us. Without these microbes, in fact, I was pleasantly listening, I was so happy to listen to the AMD group just before getting into this auditorium, that bioleaching and some of those processes, the AMD has initiated, the first one to initiate those processes involving microorganisms, which means the minerals that are cycling and recycling of these minerals has to happen through several of these microbiological processes. Without that, it is not going to be easy for us to get these things available in the form in which they are made use of. Of course, there could be chemical processes. That's a different story. But biological processes are also very well known for the cycling of minerals. Maybe a couple of examples will come as we go along with a few slides that I have made. Most of them are colorful pictures. The children don't worry about reading the content. You try to get the message out of it. And those who can read and understand some sentences of that, you can read wherever some sentences are there. I don't want you to load with too much of a science, but at the same time, I want you to go with a take-home message that microbes are important. Microbes may be harmful, but they are also important. They can help us in many ways. And let's see in how many ways they are helpful. While doing so, I would like to restrict myself, because if I have to talk broadly about how many different ways they are useful, again, it will be a ocean. I thought I will restrict myself to a small area where we talk about plant health. How microbes are helpful in maintaining the health of the plants. Why should we maintain health of the plants? We should maintain health of the plants because we get everything from the plants. The fruits that we eat, the vegetables that we eat, the food grains that we eat, the oils that we use, all of them are coming from plants. Obviously, if they are not healthy, we will not be healthy. That's where I'm going to tell you something about One Health that has come into picture in science these days. If you take care of the animals, the insects, the plants, the soil, then only your health will be good. Director Saab was referring to some of the damages that have happened to the environment. This is one of those damages that have happened. When we have not been conscious of the negative impact that some of these activities can do, have already caused damage. Okay? So we need to understand, and if we have to be healthy, if we want to be healthy, all others around us also have to be healthy. This we have to understand. That is what is called One Health. I'm going to show maybe a slide or two about One Health during the lecture. So, my dear friends, I will now take you through the slides. I hope those who have joined virtually are able to see it clearly. The United Nations has declared year 2020, as Year of Plant Health. It's an opportunity to, like we are celebrating the Science Day today, to increase the awareness of science, to understand more about the importance of science, to appreciate the contributions made by the science and scientists in the past. We are celebrating this Science Day. Likewise, to increase the global awareness on how protecting plant health can help end hunger, reduce poverty, and protect the environment, and boost economic development. That is how the UN General Assembly, they thought it is important, it is appropriate to declare at least one of those years as the Year of Plant Health. That was 2020. And we are talking about sustainable development, the UN has 17 sustainable development goals. And now of those 17 sustainable development goals, there are at least more than half a dozen of them can be significantly impacted by the microorganisms and the living organisms. You look at these pictures, plants grow everywhere. You can see a dense forest of this kind. You can see them on a hilly terrain. You can see in an agricultural field. And today, we also see them in hydroponics. We also see them in hydroponics without soil now. Crops are grown without soil in a covered environment. So that doesn't mean that soil will become redundant for agriculture very soon. It is not so. It's only another way in which you can grow the crops, okay? And you also have other kinds of systems wherein not many people have understood the importance of the below ground part. Every time, only when potato is harvested, we see the importance of below ground part. When groundnuts are to be picked up, we understand the importance of the below ground part. Otherwise, you cut the things from the top and you make use of them and don't even respect that the kind of contribution that the soil has to make for the survival, health, and growth of the plant. We have not respected. And that is what is being realized in the last 40, 50 years. How important is this soil in helping the plant to do its activities at its optimum genetic potential. Look at the different kinds of plants that we can have. Some of them could be flowering plants, some of them could be yielding timber for us, some of them could be giving some oil seed, different types of things. And you have different types of microorganisms. You know, just for the small kids who are sitting in front, I would like to tell you microorganism, when we use the word, or a microbe, it is invisible structure. We cannot see that with a naked eye. We always require a microscope to see them and then for the details. And the smaller they are, the bigger the advanced microscope that we require to see their details. When we talk about what is this virus? Coronavirus. We cannot see it under microscope, the compound microscope that we have in the laboratory. We require an electron microscope to look at the structure of that kind of a smallest possible microorganisms like coronavirus. Okay, there could be some organisms which may be visible a little when our resolution of our eye power is better. Some of those macroscopic fungi can be visible. Like some of you may be eating mushrooms. Mushrooms are also microorganisms, basically. It is only the fruiting body of the fungus that we are eating. The inside, it is a fungus. It's the fruiting body of the mushroom we are eating. That's just for you to understand the glimpse of microorganisms there. And when they interact, something else happens. When plant is living separately like this here, and microorganisms are like this, different type of microorganisms like this, when they come together, when they will come together, they can come together when they are in soil, because microorganisms, let me tell you, my dear friends, my dear children, they are ubiquitous. There is a word we use, meaning they are present everywhere. You may be knowing about what is that Prahlada and Hiranyakaship story. Hiranyakaship asks Prahlada, "Where is your God? Show me." Prahlada tells Hiranyakaship, says, "Indu galada andu ledane sandehamu valadu chakri. Chakri endendu vedakina andandaya galadu danavagrani vinte," is what his answer is. Like that, these microorganisms, you set them wherever you want. You want to see the microorganisms on this surface, you will find them. That's where we are now using this sanitizer, because our hands always will have some microorganisms on their surface. Our skin will have. Everywhere they are there. You go to the ocean, they are there. You go to the Himalayas, they will be there. Wherever you go, you will find them. You go to Antarctica, you find them. They are present everywhere. And these microorganisms, when they are present everywhere, there is no way that the plants can escape interacting with these microorganisms. They have to interact with these organisms. But then, like coronavirus, there can be some microorganisms which can infect the plants and cause damage to the plants. There can be some organisms like the probiotics that we are taking, which are helpful to the plant for them to grow better. So there is a problem for the plant because they cannot do research on their own. That's what we think, right? We think that they cannot do research on their own, but they can distinguish who is my friend and who is not my friend. They can distinguish. That's a big story I can tell later, okay? But when there is an interaction, when these two come together, when with a helpful organism when it comes, it opens the door asking the microorganism to get in. When it interacts with, when it knows that it is a possible enemy, it tries to shut the door, like what we do at the main door. When somebody whom we don't want, we will not allow that person to come in. When our relative or friend comes, we open the door and happily welcome them, take the person to inside to our drawing room, sit with them, talk to them, all that. So in this interaction, there can be a meaningful interaction where they live happily together, and there can be harmful interaction also. When they cause disease, these are the kinds of problems that you see on the plant. Some of them, as if somebody has burnt the leaf. You can see all these are damaged. And hardly the plant is able to survive. You see here the regular, the jowar, and then the infected jowar. It has become completely black. And you see completely the leaf is covered by a powder. This kind of diseases, we call them as powdery mildews, downy mildews, different types of diseases we call them. And these are called blight diseases. Some of you might have heard, those who are above 12th level, you must have heard Irish famine. It's a disease, it's in fact a potato blight disease. And similarly, we have Bengal famine. This is the Bengal famine disease, where rice damaged by a fungus and completely wiped out the rice crop in the Bengal region before independence. Like this, they have a potential, like the kind of problems that we are facing with the coronavirus. Plants also have faced problems with them occasionally. Sometimes it is serious, sometimes it is mild, sometimes it is of different nature in between and all that. But let me tell you, that is only an exception. It is not a rule. There may be a microorganism which is harmful to the plant, but it will not be able to harm the plant because, you know why? Coronavirus has not infected everyone in the very first go. Even in the second wave, some of us escaped. Not because we have taken a vaccine. Even those who have not taken the vaccine also got protected in the second wave when there was a severe infection, when so many people suffered from that problem. But we still have, some of us have not succumbed to the pathogen, the coronavirus. Why? These days, after this pandemic, everybody has become alert about the immunity, the kind of foods that you take, the kind of immunity that you can have, how you can boost up your immunity. All these are the words that we have been listening to. The plants have seen these microorganisms for millions of years. They have boosted up their immunity for years. They have known these organisms that they are there, and they have their own immunity channels. Therefore, most of the time, these pathogens cannot get onto the plant. But in a rare case, yes, it happens. Like even the third wave, after a booster dose was taken by the individual, there are people who suffered from corona now. So that means there is a minor difference where there may be a possibility of this virus or a pathogen dominating the host and then still causing the problem. That is an exception. It has not happened to the majority of the people. That is a rule. Majority of them remain healthy, and exceptional cases, they succumb to the disease. So this is what we have to understand. Although there are thousands of microorganisms which have the potential, which have the capability to cause the disease, are there, they cannot cause the disease onto the plant because the plants have their own immunity against several of these organisms. Some other diseases, you see how it looks like? It's like a rust, spot diseases, leaf spot diseases. These are the beneficial ones. When the microorganism has come in, the organisms have allowed them to have a place inside. Some of you, even from the 8th standard, you must be reading. Leguminous plants have a symbiotic association with rhizobium. That helps taking the atmospheric nitrogen, which is in plenty. About 76% of the atmosphere is filled with nitrogen, but the plants cannot take that nitrogen because they don't have an enzyme which can convert the nitrogen to dinitrogen to a usable form like ammonia. Whereas this microorganisms, this tiny invisible rhizobium has that enzyme and converts the dinitrogen to ammonia. And that ammonia is released into the plant and plant takes advantage of that. Okay? So it allows the bacteria to form a house, what you call as a nodule, a root nodule. Similarly, it allows certain fungi to form this kind of a house. These are called since they are visible to outside, we call them as ectomycorrhizal fungi. Mycorrhiza, fungus and a root coming in together, we call it a mycorrhiza. And since it is visible to outside, you call it as ectomycorrhiza. And there are also endomycorrhizae, which are not visible. But both of them help in drawing the nutrients, the minerals from the soil to the plant, particularly the phosphate. Particularly the absorption of phosphate is facilitated by these mycorrhizal fungi. And some of these mycorrhizal fungi form a fruiting body, what you call as a mushroom. So these are some of the examples where the microorganisms are, when they are beneficial, how the plant allows them to be there inside. Today, I told you, now we understand more. There are several different microorganisms. What are they all doing? Some of them could be pathogens. Some of them could be mycorrhizae. Some of them could be beneficial organisms like rhizobium or other names that I have given here. Nitrogen fixers are the rhizobia. Endophytes, those which live inside the plant. And phosphate solubilizing organisms, PSOs, like this. All of them, and in addition to these, there are other organisms like free-living and saprotrophs, also there in the soil. We have not respected all of them sufficiently. Now we know all of them together, the kind of interactions that take place around this plant, not just this plant alone. Around this plant, we call this as a meta-organism. Meta-organism, how this plant should behave, how this plant should function, how this plant should remain healthy is decided by this meta-organism. Involves all of them. That's where you have to take care of all of them if your plants have to be healthy. We have to take care of all of them if our plants have to be healthy and we want to be healthy. This is the example I was showing you about rhizobium. Just, I wanted to draw your attention to one small thing. How this minute bacterium or these invisible bacterium has to come closer to the plant and establish a root, establish a nodule. It's a beautiful thing that for us to appreciate. This plant releases some chemicals, what we call as root exudates. They come out of the root. We call them as root exudates, those which are secreted by the roots. And some specific compounds which are present in this root exudate activates the genes that are present in the invisible microorganism. Then this invisible organism responds. It produces another chemical substance, what is required to form a nodule. Therefore, we call it as a nod factor. This nod factor, when it is formed on the surface of this root, then only the plant allows this microorganism to enter. If there is no nod factor, this microorganism can never form a nodule. When this nod factor has formed, only when the chemical from this plant has activated its signal. There is a perfect match. There is a perfect signaling that is there between this plant and microorganism. That's how the beautiful interaction that takes place, that love for each other happens, and then they make a home in the form of a nodule. Same things happen for mycorrhizae also. That means the plant knows what it is doing. The plant knows it intentionally attracts these organisms by secreting a specialized chemical. And bacteria responds by producing another specialized chemical, thereby both of them can form a symbiotic association. Same thing as I said for mycorrhizae, that also happens. And this is, we can skip this. I just wanted to show you how both of them together, this individually, this bacterium and this fungus. The process is same. A chemical is formed by the plant, fungus gets attracted, fungus releases a compound or a bacterium releases a compound, and plant responds. This response is, I have shown it in the form of signals here. These are the plant signals. And this signal allows them to form a kind of a structure which allows them to stay inside the plant. This here is a nodule which allows the rhizobia to stay inside the plant. What is the rhizobium giving in turn? Ammonia to the plant. What is this mycorrhizae giving in turn? It is giving phosphorus to the plant. This is another group of organisms which have been discovered. Neither they are forming a house inside like a fungus, mycorrhizae or bacteria, but nor they have their own chemical signals are yet to be discovered. In fact, chemical signals, those which are attracting these PGPR, these plant growth promoting bacteria, are yet to be deciphered completely. Some of them are known, some of them are not yet known. But then there is a chemical interaction. So the plants are not behaving just like living organisms. There is a chemical signaling always involved here. We must remember this. And therefore, a plant scientist today, if you want to be a plant scientist, you cannot only study botany. You got to study chemistry. And you got to understand physics at some stage for us to understand what was that signal and how to read that signal. So there is an integrated approach that is coming in. That is the theme of our this year's scientific science day, where we are talking about integrated approach in science and technology. The days are gone where you can do the things in isolation, where you can say, I am a zoologist and I will only look at amoeba and hydra. I am a botanist, I will look at only Annona or Brassica. The days are gone. You got to understand several other things associated with it for you to make a meaningful contribution in science. Like you can see here, 7 different ways in which these microorganisms can help. Most of them are minerals, sir. You have these phosphate, sulfate, potassium, zinc, all of them nitrate. For mobilization of all these elements, these microorganisms and microbial processes, Plants are dependent on these microbial processes for them to have soluble minerals which serve them as nutrients. Macro elements, some of them are macro elements which are required in larger quantities. Some of them are micro elements which are required in smaller quantities. But invariably, the plant is dependent on these microorganisms for its growth, for its health. I was telling you about the Sustainable Development Goals I mentioned to you. Microbial biotechnology has been contributing to at least to these many Sustainable Development Goals. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 different, out of 17 Sustainable Development Goals that the United Nations has declared, most of them are driven by can be achieved through microorganisms. So sustainability on one hand and ubiquitous microorganisms on the other hand have a wonderful link. Only thing is we should know how to use them, how to tap the potential of these microorganisms to achieve those sustainable development goals. What are the different things the ecosystem system, provision services, supporting services, regulating services, cultural services, in all this. Under this, you can see here, primarily I want you to focus on this aspect, the supporting services part of it. Primary productivity, that means how much the plants have to photosynthesize and produce the carbohydrates. How much of a carbohydrate? Productivity, primary productivity. Nutrient cycling, soil health, all of them are dependent on microbial technologies. This is how they can contribute to. I am now slowly taking you to the next level, which way I will try to finish in about 10 to 12 minutes. That would be the completion of the talk. A word that is at the top, you see a word microbiome. I have so far talked microbe. Now I am talking about microbiome. What is this microbiome? As I said, we have been talking about rhizobium. We have been talking about one ectomycorrhizal fungus, one endomycorrhizal fungus separately. But if we try to look at how they can contribute and how they can help, it's not one-to-one that is straight away you can deduce and arrive at a conclusion. There are other things around the plant, all other microorganisms which I have shown, they are all there. It is not that only this organism will selectively do the job and rest of them cannot do anything. They all will be interacting and they all can do negative, positive impacts, all that together. In such case, the net effect of a given positive organism or a negative organism is dependent on who are all there around it, who are all around us. Like in a cricket team. In a cricket team, if you have to win the match, is it sufficient? Is it sufficient if one player plays? Yesterday, who was that poor guy, Sri Lankan captain, Shanaka, made a wonderful innings, maybe some 74 not out. But then all others have not been able to do the job. Whereas on this side, Siraj has made his job. Avesh has made his job. What is Avesh? There's another bowler. Shreyas Iyer in batting. Maybe other everyone together have played, and then only there was an outcome there. There was a positive outcome there. Like this, it's a team. And when you have several organisms together, the interplay of all these organisms comes into picture, which people have not been able to understand until recently. Now we know, oh, come on, you cannot look at only individual. You have to see who are all around. Then only you can take a decision. You can interpret. Those who are all around, all those who are together constitute all microorganisms together present in a given environment. We consider that as microbiome. So microbiomes can contribute to sustainable development goals. Not microbiome. Now, I draw your attention to this slide. Those of you who can read, you read. Otherwise, you don't worry about that. In around 2000, around the turn of this century, Human Genome Project was completed. We know how many genes are there in human being and what these genes, some of them, what they can do, what they cannot do, all that we have studied, we try to understand. Around this time only, the concept of microbiome has come in, that we need to understand all the organisms that are there in a given zone together, not look at them individually. Earlier, we were only looking at E. coli in the intestine. Oh, come on, you cannot only look at E. coli, you have to see all other organisms which are there in the intestine for you to understand what the E. coli can do there. In the gut, you may have a different type of population. My gut will have a different microbiome versus her gut versus Director Sir's gut. What influences that? Your genetic makeup, your food habits, and all such type of things influence what should be the gut flora in my gut versus your gut versus others' gut. And they can influence your health. There are at least 20 different ways people have shown. The way you think, the way you do your things also are influenced by some of the microbes. The way your skin has to be protected is taken care by microbes. The way your intestine has to function is taken care by microbes. There are 20 such things at least identified so far. That means once there are scientific advancements, when you started looking at them in a holistic approach, in an integrated manner, a holistic approach in an integrated manner, then you start realizing more and more finer details in the system, whichever system we are talking. That is how then the human microbiome has become important. Those of us who are following common articles in newspapers and some magazines related to health, we realize so much of it is being done. And 5 years ago, when I was in United States in MIT, most of the neighboring startup companies, every third person or fourth person was talking about, sir, we are working on how to develop microbiome-based products for human health. Microbiome-based products for human health. Before that, we only know some probiotics. Today, we are reaching towards precision medicine, making use of microbiomes. Precision medicine, meaning for a specialized disease, specialized composition, and design it, and then give it to the patient. And one, maybe, of course, science, when we are talking in science, nothing, we don't have to worry about it. There is something called fecal microbial transformation that has been used as one of the therapies. That means the microorganisms from a healthy individual, from the fecal matter, they are cultured and given to those who are suffering. And that alleviates the problem and that protects the individual from the disease. Fecal microbial transformation is what it is called. So it is it's not only for human being it is important, it is also important for plant. It is also interacting with these microorganisms everywhere, be it in the air, be it in the soil, wherever it is. The fruit is if some of us think that we have washed the fruit and then eating that is free from microorganisms, forget about it. If we think that we have washed our vegetables and then cutting salad and then eating it, don't think that you are free, that is free from germs. But don't worry about it also, but those germs are not harmful. There are always some endophytes associated with them. So what is there in a cucumber may not be the same in carrot, may not be the same in tomato. They are different. You have different microbiomes, endophytic microbiomes in different plants. But each one of them has its own significance. I will not get into this. This slide is only to show to you how chemical molecules and their signaling processes are important in deciding the outcome of these interactions. So much of it is there between them. It is not that as a random event it happens. It happens through a specialized process, specialized chemicals, and then exchange of chemicals, which I have explained in terms of rhizobium there. And how they activate the genes and then make the plant or microbe respond to those. That's where I was telling you, a reductionist approach where you start looking at one parameter at one time. Research has been, until 20 years ago, one parameter at a time, because your resources are limited, your thinking process is limited, so many things were limitations. And some people say that instrumentation was limitation. But because that instrument is not there, I could not study. Whereas Raman, as Mamlanji has read out, required hardly any instrument to discover something what was worth the Nobel Prize for him, what fetched a Nobel Prize for him. Instrumentation cannot be the limitation all the time. Rarely in an exceptional case, instrumentation may be limitation, but your imagination is the limitation most of the time. And today, instead of using, people started working with small one organism and then stacking them together and then working with some kind of consortia, a group of them. But that is also not sufficient. We need a microbiome. The holistic approach is what is required today for us to understand from the experience of the human microbiome. What we have done in agriculture, I think that's the last part that I'm going to deal with next 3-4 minutes. What we have done in agriculture, we have ignored all this. We have not taken serious note of the insects which are useful for the plant for pollination. The insects which can eliminate the harmful insects, we have not bothered about them. We have not taken sufficient care of them. We have not taken sufficient care of what is there on the surface of root, what is there in the soil, what is there on the surface of leaf, what is there inside. All of them we have not taken care, because we are driven by intensive chemical agriculture. We were driven. It was a necessity. Let us remember, it was a necessity. You cannot afford your people to be hungry, to go hungry, and therefore we have adopted a green revolution, and we continue to practice that green revolution, wherein there was a need for us to spray chemicals as the nutrients, spray chemicals as pesticides, spray chemicals as fungicides, spray chemicals as weedicides. All this has been chemicals, chemical intensive. What was the net effect? Our soils have become completely impoverished. Our water bodies have become contaminated. So many other things. Our food chain, in fact, our food chain, most of the cancers people believe are due to hyperaccumulation of some of these toxic substances inside the body of the human beings. Even if I'm a vegetarian, I would have taken in lots of those pesticides. And if by chance, if it gets accumulated in a certain location in the body, maybe at a threshold level, it was sufficient enough to trigger the oncogenes and for the cause of the cancer. Like this, there are problems associated with that intensive chemical fertilizer where we have ignored all that. And for us to make this agriculture sustainable, to ensure that the future generations are not deprived of an opportunity to grow the plants in the soil, we have to protect this soil. We have to make sure that the soils are back to the normalcy. And we have to ensure that these water bodies are not contaminated. And we have to ensure that the food is not toxic. Only then we are allowing the next generation to live at least the way in which we have lived. That is sustainability. So agricultural practices can cause major harmful effects to the crops associated microbiomes. What they have done, they have reduced the microbial diversity. That is a problem. They have altered or impaired the microbiome functioning. These chemicals. Disruption of many beneficial relationships between plants or insect hosts and symbiotic organisms like rhizobium. We therefore look for a systems approach for agroecosystems. Don't look at agriculture as growing monoculture of rice, maize, or wheat. Look at agriculture as agroecosystem, like our forefathers have practiced, where animal husbandry was part of it, where other things, the usage of organic fertilizers. They were major players in, that's where there is a shift towards the organic farming. Although there are limitations in the organic farming, unless we bring to certain level, organic farming may have its own limitations, but there is a shift towards that. Presently, Government of India in the last 3 to 4 years particularly have put heavy emphasis on this organic farming. There, in the recent budget, our finance minister, Nirmala Sitharaman, made an announcement that there will be incentives for the farmers who are getting into this organic farming. That means the government has realized the importance of the damage that has happened and the reason that they need to come back to the normalcy, and that's where they are promoting this organic farming. That One Health. So this, looking at systems approach for in agroecosystems rather than looking at individual components, is what is One Health. Take care of animals, take care of microorganisms, take care of insects, take care of the plants, take care of the soil, take care of water, everything. That is only, then only we can be healthy. We are talking about plant health. For that to be healthy, we have to take care of all this, and then only we can be healthy. Remember this. This is One Health concept. So there are comparative things. Dietary changes can help. That is soil management, a comparison on plant side and human being side. This is fecal matter transformation that I was talking about. Complex communities that I have shown, microbiomes. Microbiota-based products, single inoculants earlier were available, and now towards precision agriculture, towards precision medicine. These are the major applications that are coming, which can influence, which come under bioeconomy and environmental microbiome. This I think I will skip. It is not required. This will be probably the last slide. The future perspectives of integrated rhizosphere microbiome management. We need to, after understanding the importance of the microbiomes inside the plant, surface of the plant, surface of the root, in the soil, around the insects, if we understand the importance of these microbiomes all around, then we will be able to do a better job, and that's how we are going to take care of the agriculture in the coming years, with all these kind of different types of microbial inoculants that can be made available, customized inoculants we call them. For a given crop, you can have a customized set of inoculants, a microbiome inoculant, and there are companies, my dear children and audience, companies which have come not only abroad, also in India, not about human microbiome products. Plant microbiome-based products are available today in India. They are coming up in a big way. For those of you who have concern for it, those who are capable of thinking differently, you have an avenue to develop this kind of products for agriculture and help the country to transform, to bring back, at least I would say, to bring back the health of the soil, the health of other things that we have lost, for us to have One Health through sustainable agriculture. So my dear friends, microorganisms are important for us to have a sustainable agriculture, because they are important in cycling. They are also important in doing several other things which I have not listed here. That will take away the focus of the talk. Therefore, I have not talked about all those things. So with this, once again, I would like to thank the director, Dr. Sinhaji, and his team, all of them, for thinking about me to share my thoughts to all of you, those who are here and those who are virtually who have joined this meeting, extending the Science Day greetings once again and thanking all of them and all of you for this opportunity. Thank you.
Yeah. Anybody has any queries or anything you would like to know, especially the students? Anybody who would like to know something more in this field? Any innovative ideas which you have? You can share with Sir or you can ask him. Don't feel shy, just come out with your questions, please. Thank you so much, sir. A beautiful talk striking a balance between the senior scientific community and the students, emphasizing upon plant health and the role the friendly microbes play in improving the plant health, in sustaining plant health, in turn helping sustainable agriculture, essential for our long-term agricultural needs, and how the integration of the three basic sciences is a necessity to make an impact. I now request our director, sir, to present a memento as a token of our appreciation to our chief guest. So we'll have the prize distribution. The names will be exhibited behind you. So, yes. If you don't mind. ये chairs हटाना है.
Please speak about the competition that we have conducted.
Huh?
Briefly speaking.
Yeah. Now we have come to one of the most interesting parts of this program, and that is the prize distribution for the competitions which Mamlan sir has already told were held. That is a quiz and essay competition. So there were two competitions, and in both the competitions there have been made 4 groups. One is from 6th to 9th, the other one is from 6th to 8th and 9th to 12th, and undergraduate colleges and postgraduate colleges. So that is how we are going to, there are so many names, and it's beautiful to see that there has been participation from all corners of our country and even the remotest parts. So that is really applaudable. And now we will just start with I'll just read out a few names because of the paucity of time. I'll not be able to read all the names, but we are going to display all the names. So the first one is the essay competition. The classes from 6th to 8th. The first prize goes to Ayush Kumar Manna, AECC Turamdi, Jamshedpur, first prize. Then Kanak Agarwal, Subodh Public School and Western Region, that is second prize. V. Mehul Chakravarti, Visakha Valley, Vishakhapatnam School, BSY Vizag, that is third prize. And B. Hasina, Oxford Universal Public School, Bangalore, SR, consolation prize. Tulika Bharadwaj, St. Claret School, Shillong, NER, that's also consolation prize. This is for the 6th and 8th. Now we go to the 9th to 12th classes. Janvi Hegde, Vidyaniketan Public School, Bangalore, SR, first prize. K. Ramya Padmaja Reddy, Vijaya School, Sikandrabad, SCR, second prize. Harda ML, GNGHSS, Trivandrum, BSY, Trivandrum, third prize. Neha Jose, KVS, Arunachal Pradesh, NER, consolation prize. Kajal Gupta, DAV Public School, Sonbhadra, UP, NR, consolation prize. Then going to the undergraduate colleges, Anirban Das, St. Edmund's College, Shillong, NER, first prize. Swati Chaudhary, Ramlal Anand College, Delhi, NR, second prize. Rohini Sachi Gartia, BSOI, and she's from Ravenshaw University, Odisha, that is third prize. Then Bhuvnesh Kumar Pradhan, and Karim City College, Jamshedpur, ER, consolation prize. Supriti Khatri, St. Edmund's College, Shillong, NER, consolation prize. Then we go to the essay competition for post-graduation colleges. Lucky Star, Northeastern Hill University, Shillong, NER, first prize. Priya Kumari, Jamshedpur Women's College, ER, second prize. Gunnu Punnu, RTM, Nagpur University, CR, third prize. Jivika Mishra, Ravenshaw University, Odisha, again, BSOI, Vishakhapatnam, consolation prize. Manisha, PG College, Haryana, NR, consolation prize. Now we are going for the quiz competition from 6th to 8th category. Rishi Shekhar, Kendriya Vidyalaya, Sector 4, RK Puram, NR, first prize. Sativada Advit, Kendriya Vidyalaya, Jalahalli West, SR, first prize. Rishabh Chaudhary, DAV Public School, Bishtupur, ER, second prize. Brianna Jinu Mathurs, Kendriya Vidyalaya, AFS, Ernakulam, BSOI, consolation prize. Titiksha Panda, Kendriya Vidyalaya, Nehu, NER, consolation prize. Now for the 9th to 12th category, Divya Kapil, Kendriya Vidyalaya, Sector 8, RK Puram, NR, first prize. Akriti, Kendriya Vidyalaya, Belgavi, SR, second prize. Maharna Goswami, Kendriya Vidyalaya, Nehu, Northeast, third prize. Chevuri Tanmay, Raghunath High School, SCR, third prize. Prashant Pratap Singh, Baldwin Farm Area High School, ER, consolation prize. For the undergraduates, Shraddha George, Mahila College, Chalbasa, ER, first prize. Faithful Sir Kharbini, Shillong College, NER, second prize. Tamanna Priyadarshini, Government College, Sundargarh, BSOI, Vishakhapatnam, third prize. Vikas, Government College, Narnaul, NR, consolation prize. Sanket S. Kamte, RLS Institute, Belgaum, SR, consolation prize. Then we go to the post-graduations. The post-graduation colleges, Sartab Jaina, Samalpur University, BSOI, first prize. Chintalapudi Sridevi, Andhra University College of Science and Technology, SCR, second prize. Then Doling, Northeastern Hill University, Northeast, third prize. Akhil Ajay, Sri Narayan College, Varkala, consolation prize, BSOI. Nafisa Parveen, Jamshedpur Women's College, ER, consolation prize. Rest are the list of the consolation prizes which will be following. You can just have a look at them. So they were the consolation prizes for the essay competition of from all these places. So as we can see, the participation has been really from far and wide, from the remotest parts of our country, and that is really very, very appreciable. So I think, yeah, it's okay. So as we draw the curtains on today's program, I would like to thank all those who tirelessly worked for today's celebrations. On behalf of Director and the entire AMD family, our sincere thanks to Professor P. Apparao for accepting our invitation. We are grateful to our Honorable Director and all the additional directors for their unstinted support. I thank each and every section involved to make this program a success, which goes out to security, canteen, library, PMSG, engineering section, instrumentation, and all the committee members. Last but not the least, a big thank you to the entire audience, online and offline, especially the students and their faculty for being there. Namaste. Now we shall rise for the national anthem.
अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड़ उत्कल गंगा विंध्य हिमाचल यमुना गंगा उत्कल जलधि तरंगा तब शुभ नामे जागे तब शुभ आशीष मांगे गाहे तब जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता